Welcome. Today we are going to see what is an API. What's an API? Well, API stands for Application Programming Interface. It's an interface which lets two systems communicate with each other. A system can bundle all the services and features that it has to offer and expose them using the endpoints. For instance, in our web application, we know client server architecture, correct? So we have a client which makes a request to a server and gets back a response. Similar lines, we have API. A system can actually expose its services so that other systems can consume it. A simple example is WhatsApp, which is integrated with Google Maps. So we can easily share our location in a message. Now that we know what's an API, why do we have an API? Answer is simple. We don't have to reinvent the wheel. Meaning, it allows developers to add specific functionality to the application without having to rewrite the same functionality again from scratch. API allows developers to access data from other applications. So it makes our life as developers easy and helps develop code faster. Before we consume any API, there are a bunch of questions that we are supposed to ask. Like, what kind of API it is? What's the data format that it uses? What kind of authentication or authorization it is using? And most importantly, what are the functions that are available for us as users, as developers that we can consume? There are common forms of APIs like web APIs, library APIs. As the name says, web APIs are the APIs which are accessible via or over the web. Library APIs, on the other hand, is an API that we can include in our project, in our solution. So, web API types. Well, there are four types of web APIs: public APIs, private APIs, partner APIs, and composite APIs. Public APIs, as the name says, these are the APIs which are publicly made available, meaning there are no restrictions to access them. And so they are available for everybody's use, right? Private APIs, on the other hand, are the APIs which are available not for public use, meaning if we have an enterprise, we have different set of teams, correct? So each of the teams will have a set of APIs that they want to expose so that other teams within the same organization can actually use it. So that's the use of private APIs. Next is partner APIs. So these are nothing but a set of APIs. In order to access these, a developer needs to have specific rights or licenses in order to access them. So that's like access to a paid for service sort of APIs. Restricted access. So that's what we have to remember here. The other set of API known as composite APIs. So this type of API combines different data and services. Okay, it's like it allows, we can say, it allows developers to access several endpoints in one call. So it could access different endpoints in a single API call. Okay, this is very useful in microservices sort of microservices architecture, where a user may want to have information from several services to perform a single task. So using composite APIs can reduce it can not only reduce the server load, but also improve application performance. As in one, because in one call we can return all the data that the user needs. Next concept is API architectures. Well, we have REST, JSON RPC, and XML RPC, and so. So REST is an architectural style where we expose REST is a very powerful web API architecture. For any API to be REST API, it must adhere to certain constraints or principles. For example, it needs to have a client server architecture, as I mentioned earlier, right? So these are two separate systems. There's a client, there's a server. So there's like distinction between each of these. And then the API must be of stateless in nature, meaning there should not be any client context that has to be stored on the server between multiple requests. Cacheability is another principle that drives REST APIs, which means that client have a flexibility to cache the response that they have got back from the API. So the REST API must explicitly state whether it can cache the response that it sends or not. Another feature for REST API is layered system. So in this, API will work either directly with the server or through a load balancer systems or intermediate several couple of intermediary systems. Doesn't matter. It can have a layered architecture, but for the end user, he is going to interact to the entire system as a whole. And the other feature is code on demand. Moving on, JSON RPC and XML RPC. RPC stands for Remote Procedure Call. So this is a mechanism which is designed to transfer, or rather we can say call methods which are remotely deployed on a server, as opposed to REST, which involves transfer of documents, or let's say resource for that matter. So REST works with resources, and RPC is all about actions, executing a remote method on a server. Next is SOAP. So SOAP, we can say that SOAP is like RPC. It uses the RPC pattern, wherein we have functions or methods, which are used, which we pass in certain parameters and get back a response. But it is different from RPC in the sense it is programming language independent and underlying transport protocol independent. SOAP stands for Simple Object Access Protocol. So it's sort of like intended to be extensible, neutral. It can have, or we can rather use a range of protocols, including HTTP, SMTP, TCP, etc. So now we have talked about APIs, and we said that APIs are ways for two systems to communicate with each other over the network. Or we can use use them as library APIs, where we can have the jars downloaded into our web application, and extend or build upon features using those. The one big question that pops up is, what is the difference between web services and APIs then? The answer is simple. All web services are APIs, but not all APIs are web services. Can you guess why? Simple. Because as we said, APIs can be accessed over the web, or library APIs. That is, we we can have them as library APIs, but all web services have to have, or are accessible only via network, the internet. So that's why we say all web services are APIs, but not all APIs are web services. There's another very good concept known as webhook APIs. So this is a type of API wherein, see, so far we have seen that we have an API, we make a call, we call it, we send it a response in the format that it describes, and then we get back a response. So make a request, get back a response. In webhook APIs, what happens is, it's typically the API which will notify us, our system, when something happens. So it's the other way around. Instead of us contacting the API and getting the feature, it's the API which will contact us, our system, and just notify us. Contact us in the sense, just notify of something that happens. There's a very good example, or very important use case of it, is in the billing system. See, imagine we don't want to continuously make requests to a API to see if the payment is successful or not. So you imagine you make a payment, and then you keep continuously calling it, okay, was it successful or not. Instead, how nice will it be, the system itself notifies us, okay, the payment is successful. So that's where webhook APIs comes into picture. So always remember billing systems. So that's all, friends. Thanks for watching. Happy learning.